based on the temperature behavior, based on the temperature behavior, based on the temperature behavior, our Earth's layer are also being categorized. And I told you about that. We have a troposphere, stratosphere, mesosphere, thermosphere, and exosphere, which is the last. So these are what? These are the non-uniform one, and these one are what? Uniform one. These are non-uniform one. Heterogeneous, homogeneous. Based on the pattern of temperature, we can also have a layers in our atmosphere, among which the topmost, or let's say, sorry, the lowermost layer, topmost with respect to the surface. So with respect to the nature of temperature, the lowermost layer is being known as what? Troposphere. And troposphere height, I told you, it used to vary. Okay, it used to vary. Usually its height is from 10 to 12 kilometer. Okay, 10 to 12 kilometers, sometimes maximum 18-kilometer height is also being there. Now this troposphere, in this troposphere, uh, almost 75 to 80% atmospheric mass, that means gases are there, that means solid particles are there, that means water vapor is there. So all of these will be concentrated with respect to 75 to 85% in this troposphere. And yes, in the troposphere, I told you temperature used to decrease at this rate, lapse rate 6.5 degrees Celsius. And all the weather phenomena, whether there is a cloud formation, storms, cyclones, rainfall, all of these will confined to troposphere specifically. Means with respect to the weather activities, troposphere have a like a greater role to play. Sorry. And yes, troposphere will end at a tropopause. The tropopause act as a boundary layer, and convection, you'll get to know about this convection will also confine till the troposphere. Just like the mental convectional currents, we also have a convection in our atmosphere itself. You'll get to know in the pressure. I told you that many of the concepts are interlinked with each other. So it is not possible technically to explain the convection process here because it's a very lengthy concept. We will be deviated from our particular topic. So as of now, just remember what is convection. Convection means when we have a vertical movement of energy, that is what convection. Okay, so similar vertical movement of energy is also there in the troposphere, and that is confined to the troposphere specifically, that is not there in the stratosphere. Okay, moving ahead. Second layer is specifically stratosphere. Second layer is what? Stratosphere. Stratosphere is there. At poles, its height used to less. Even at poles, you can see the height of stratosphere at 8 kilometer. And yes, in the tropics, you will see the height at 50 kilometers. So it used to vary. So the concentration of these layers, let's say this is Earth, and this is what, say, you can say troposphere. Then you can say, okay, this is the stratosphere. In this way, we have a some sort of deviation. That's why it is not what mathematics. That's why there is no exactness. And I'll tell you with respect to the concepts which we are about to learn. In those concepts, I will tell you that why there is a height differentiation with respect to the different layers. So stratosphere temperature initially constant, but it rise because of the ozone. Why? Because ozone used to absorb UV radiation. UV radiation is what? High energy particles, you can say, or let's say having a high energy. And because of this absorption of high energy, what will happen? Because of the absorption of this high energy, temperature will going to increase. Why we used to see temperature? Why we used to see a rise in temperature at the earth's surface? Because it's the surface which used to absorb the sunlight, which used to absorb the incoming solar radiation. So similar absorption is done with respect to the stratosphere, and their temperature will also going to increase, same as that of the earth's surface. Here there will be a calm condition, and I told you most of the weather related activities will be confined in the troposphere itself. So clouds will be in the troposphere, clouds will not be there in the stratosphere. So as In the stratosphere, like there are no cloud. This region is cloud free. As a result of this, it is perfectly suited to the aviation. It is perfectly suited to the aviation. It is best for aviation because when you when you travel in the troposphere, there will be air drag. But when you travel in the stratosphere, the air drag will not be there because two things. Here the density is more in troposphere. Here in the stratosphere, density is less. So less density, less drag. First thing. Second thing is what, that here in the stratosphere, the clouds will not be there, or let's say almost less negligible clouds will be there. 1% could be there, but almost negligible clouds will be there in the stratosphere. You will see majority of the clouds, almost you can say 90 to 99% clouds, those could be confined in the troposphere. So visibility concern is also there, drag concern is also there. So aircraft used to fly in this way. They will take off, they will go through the troposphere, then they will going to fly in the stratosphere, and then they will again take the same thing, do the same thing while landing. So in this way they used to save their fuel. I mean, this is what one of the exercise through which they can save their fuel and become economical. And yes, this stratosphere filter UV radiation, and that's how it is also protecting the earth. UV radiation will not arrive on the earth's surface, okay, because the absorption is taking place, because the absorption is taking place. Right. So here we have a oxygen. So it will going to absorb the ultraviolet radiation, will going to absorb, and that's how the oxygen will going to convert in terms of ozone. So the places which are on the earth's surface, they will not see ultraviolet radiation. So it is the stratospheric ozone which probably save us from what, from ultraviolet radiation or the cancer instances. So it act like a blanket to the earth's surface. It protects us from the ultraviolet radiation while absorbing the same and transforming the oxygen into ozone. Okay, so next layer is mesosphere. The extent of mesosphere is from 50 to 80 kilometer. Temperature used to drop at the top, or let's say at the end of mesospheric layer, the temperature used to minus 90 degrees Celsius. It used to protect the earth when there is a meteor. So when the meteor is coming, suppose the meteor is coming in our earth's surface, so here the density is almost negligible. In the exosphere the density is there, in the thermosphere the density is there, in mesosphere the density is there. And yes, you must remember that there we have a density difference. The density of D3 will be greater, the density of D2 will be less, and the density of D1 will be least. And if we move further with respect to the D4, the density will be greatest. And yes, with respect to the D5 in troposphere, the density will be maximum. So when the meteoroid is coming, the meteoroid is actually moving through the different density of air. And with this different density of air, there will be a what, friction. As a result of density difference, these meteors will be light up in mesosphere specifically. So when we have a meteors, and when they are about to pass through the mesosphere, they will be a, they will going to catch fire, and as a result of that, that mesosphere would going to protect the civilians, or let's say the life on earth, that it is not allowing these meteors to strike on earth's surface because of the different density. And it is widest one, okay, it is one of the widest one. There are large zones through which these meteors have to pass in terms of mesosphere. So in the mesosphere we have a density difference. As a result of that, these meteors used to catch fire. And yes, this is the layer which is protecting us. It is the layer which is protecting us from the meteors. So it is what, one of the blanket which protecting us from meteor or from the any other celestial bodies. And for the mesosphere itself, there is a beginning of ionosphere. And we will see that what is the role of ionosphere. Ionosphere is responsible for reflecting the radio waves in order to foster the radio wave communication on earth's surface. Mesosphere. Moving ahead, Then we have a thermosphere. The height used to vary from 80 to 400 kilometer. And in the thermosphere, temperature rises sharply. Temperature rises sharply, but low density of air is there. Okay, the density of air is low here because the gravity will have a less force, or let's say less influence here, not force, less influence here. And sometimes it might feel cool when the sun is not there. And it is also, I hope you remember, with respect to the mesosphere, we have a beginning of ionosphere. Throughout the thermosphere, throughout the exosphere, we have what? Ionosphere. So it also contains what? Ionosphere. Here there will be a radio wave reflection. Here you will see we have a auroras. You will get to know what is the aurora. So here we have a auroras, we have a meteor entry. A space station and satellites used to orbit in this specific thermospheric layer, in this thermosphere layer. Exosphere extended up to the height of 400 kilometer. Okay, and even beyond that, it is the outermost layer which is having a some sort of boundary with the outer space. It is extremely rare field. Here the gases which are there, the gases will be rare in terms of their density. So rare density gases are there in exosphere. And yes, helium and hydrogen will be here because they are the lightest one. And yes, this exosphere is under the direct exposure of sunlight, though the atmosphere's direct exposure is started with the exosphere itself. Thermosphere will also expose, but yes, majority of the sunlight would going to filter out by the exosphere, and yes, with the successive layers as well. So this exosphere will have a direct exposure to sunlight, and as a result of this, temperature will going to increase. And yes, with the increase in temperature, you will see that with the exosphere, we also have a solar flare. Okay, when there is a electromagnetic radiation from the sun surface, that will also going to affect the exospheric conditions in our atmosphere. Okay, moving ahead. Then we have a ionosphere. Now, what is ionosphere? Ionosphere lies in mesosphere. So from mesosphere we have a ionosphere. From mesosphere throughout the thermosphere and even in exosphere we have what? Ionospheric layer. These are just for reference. D layer, E layer, and F layer, just for reference. Okay. So the lowermost ionospheric layer is D layer, E layer, and F layer. F stands for fly. Just to remember, just for remember or mnemonics. So this ionosphere lies within the mesosphere, thermosphere, and yes, exosphere. And with respect to this ionosphere, what we can say that in this ionosphere we have ultraviolet radiations, we have X-rays, those who are coming from the sun. And yes, we have a ionization of particles. So here we have a particles, and the particles, those who are there, they will be under the exposure of sunlight. Whenever we have an exposure of sunlight, due to that of UV light, due to because of the intense energy burst in form of solar flare, in form of solar winds, as a result of that, what could happen? The particles which are there, they could be charged. Particles which are there, they could be charged, and they will be termed as what? Ionized particles. So this ionization is taking place in this entire ionospheric layer, which is comprised itself, which overlaps with mesosphere, thermosphere, and exosphere to some extent. So it contains what? Charged particles, and these charged particles form mainly when the oxygen and nitrogen atoms which are there in atmosphere, when they used to interact with each other. Here in the upper atmospheric region, for example, up to the height of 60 kilometer, or like in between the 1000 kilometer, where the solar radiation ionize the gas molecules, there will be a production of free electrons and ion. Here there will be free electrons and ion, and act like a these act like an antenna for radio wave communication. These act like a antenna for radio wave communication, because they used to reflect radio waves. So they used to reflect and refract radio waves, which is crucial for long distance communication. And yes, radio communication, which is there, GPS accuracy, which is there. So it is very helpful I mean, this particular F layer is very helpful with respect to the understanding space weather as well. So ionosphere is a one of the most important layers with respect to the understanding of space weather, and yes, with respect to the behavior of radio waves because of these charged particles. How these charged particles are there? Because of the high energy insolation which is going through the ionosphere. Air will be ionized. As a result of ionization of air will be ionized because of the ultraviolet radiation, because of the X-rays. When the air will ionize, the free electron and ions will be released in atmosphere itself. They will going to act like an antenna. They will going to reflect or refract the radio waves in order to foster the radio wave communication on our earth surface. It's because, see, this is our earth. Let's say this is the place A where you can place a transmitter, and here we have a B place where you can place what? Receiver. So there is a one concept called as LOS, line of sight. Communication can take place with respect to the straight line, but here, because of the curvature shape of our earth, in that way the radio communication will not going to foster for a longer distances. So what used to happen when this there is an ionosphere, and in ionosphere we have electrons and ions, so there is a transmission. So electrons and ions which are there, they used to reflect and they used to reflect the same waves, you can say, and that's how the radio communication is being facilitated. All right, so that role is being played by ionosphere. So in this session we actually discussed about the feature, I mean the way in which temperature used to behave when it used to be there with the different layers of our atmosphere. We got to know about the different composition of these atmospheric layers, and yes, we got to know about the density, pressure and temperature feature, whether it will be fall or whether it will be increase while moving through these layers or successive layers. In next session, we will be discussing about some more aspect in continuous. Till then, take care, study hard. Bye.